we build proposition from other propositions by something called operator. So what is that? It's basically 1 plus 1. The plus is an operator. You connect stuff to make new stuff. The plus sign is an operator. 3 times 4 is 12. The times is an operator. So this kind of thing is called operator. And in logic, you have the following: and or not, contradiction, tautology, exclusive, or blah, 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 blah. And here are some examples. I am not happy. I am not happy. I can use any symbol to represent I am happy. So suppose I call happy, right? So I call H. So H means I am happy. Now I want to negate it. That means I want to flip it to negative. So what I do, I just write this symbol, okay? And then from the previous page, you have other way to write it. In programming language, you cannot draw this funny symbol, so you use a exclamation mark or this symbol to do negation. So this is like what? This is like negative in number, okay? And then here's another example. He is tall and he wears glasses. Okay, he is tall is T. I just said T means he is tall. He wears glasses. Okay, this should be S, but anyway. So G. So he is tall and he wears glasses. N. It's like this. So this represents N. And now this one, you see so many things. This is a funny one. So there are 2 or in logic. The first one is or. The second one is exclusive of. What does it mean? I go to school by bus or on foot. It means this is inclusive or. That means I either do one of them or both of them. So for example, I may go to school by bus for the full trip. That means I walk 0 steps. I cannot walk. If I need to go to the bus station, I have to teleport or I fly. If I walk 1 step, that means this sentence is wrong. We are not talking about common sense. We are talking about logic, okay? So I may go to school on foot for the full trip. That means my foot cannot step inside a bus. Or I may have this. This is common sense. I have to walk to bus station and then I take the bus. So in this case, this means this or means these 2 things happen at the same time. Please make sure you understand this, okay? I use crazy example like this because this gives you a strong impression. That means you remember this, okay? And then here's an exclusive or. In a restaurant, this or have a meaning. You only have one of them. So these 2 or are different, okay? And the symbol, well, and it's like this, then or I just draw the opposite direction. And if there's an exclusive or, I add a minus sign below. So something like this. Now we have the implication. So if blah, 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 then blah, blah, blah. So what does it mean? It says if n in the natural number is even, that means 2, 6, 8, whatever thing, then n squared is divisible by 4. The first sentence is blah, 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 right? I call it E. The second statement is divisible by 4. Okay, I call it D. So this thing in symbol is E implies D. Okay? And then the second line, this is called if and only if. What does it mean? N is even if and only if n squared is even. So first guy is even, right? I call it E. The second is n squared is even. Let me call it E2, okay? So if and only if, so that means this is the first if. Only if is the opposite. So that means I have this. So that means what? If and only if is this thing, logic, and this thing. Okay? But people are lazy, don't want to draw this, okay? So they draw this. Okay? Here's a it is what it is. This is called tautology. Why? Because this is always true. So this is called tautology. To be or not to be. Okay? If I let to be start with T, right? So T. Not to be. That means not T. Or. So I have T or not T. Not T is false. So I have T or false. True or false is always true. So therefore it's tautology. This thing, or if I have a true and a false and an or then, it's always true. So therefore this is tautology. We'll talk about it later. Don't worry. My sister is jealous of me because I'm the only child. This is a contradiction because if I'm the only child, I have no sister. This shouldn't exist. Okay? If my sister exists, then this sentence is false. If this part is true, then this part is false. So always false. Then it's contradiction. A tautology is no matter how you declare it or how you consider it, it's always true. A contradiction is total opposite. It's always false. You can think of it as tautology is 1. Contradiction is always 0. Tautology is like 1 in mathematics, and contradiction is like 0 in mathematics. And what about liar paradox? Liar paradox is not a proposition. Liar paradox can be true and false at the same time. So it does not belong to a proposition. So that means what? It's not a contradiction. In English word, we will say liar paradox is a contradiction, meaning that this sentence is something error. But in logic, this guy is not even a proposition. This means does not belong to, we will learn it in set theory. That means what? If liar paradox does not even belong to proposition, we don't even say liar paradox is a contradiction in logic sense. We just say it's something else. It's not a proposition, so we don't talk about it. And then here are some symbols. So contradiction, tautology, this is and, this is or. These three are all not. Okay, this is if. These are just fancy name. Okay, this is if and only if. These four we talk about later. Okay, and in university level we never do this dot 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 and dot dot dot. So don't use it. And here are exercise. Okay, do it in your spare time. If and only if later. So now let's talk about the four basic operator. It's not, identity, tautology, and contradiction. So just like this. So suppose I have a P and the true value is 1 and 0. This one is called truth table. Okay. Not P basically means you flip the true value. 1 becomes 0, 0 becomes 1. Right? Identity means do nothing. If you have studied linear algebra matrix, identity is the same thing as the identity matrix. You multiply identity matrix, you do nothing. So if this is a 1, you get a 1. If this is 0, you get a 0. What's tautology? Okay, this is error. This is not 0. This should be 1. Okay, I make a mistake. Tautology means what? You turn everything to 1. Contradiction what? You turn everything into 0. So that's the meaning. And what about the last line? The last line is saying that this thing is unary operator. That means I only have one guy and I will have a symbol. Can I rewrite this as two things? Yes, you can rewrite everything in this sense. That means tautology is same as P or true. P or true. And contradiction is the same as P and false. Okay, what about this thing? This is P not and P. Okay, we learn about it later, don't worry. Okay, so this is the basic operator, and the table is called truth table. It's invented by this guy. This guy is a PhD student of Russell, and he is the author. In his PhD thesis, he writes this thing, and in the last sentence in this book, it says, whereof one cannot speak, there one must be silent. Basically means if you don't know the stuff, shut the up, something like that. Okay. Then what about unary? Unary means one, uniform, so it means one form. Universe means one verse. And univariate calculus means one variable calculus. And then these four symbols basically are all the four possible things you can get for unary operator. There are only four possible cases. So therefore, there are four symbols here. And then this table looks weird, right? Let me tell you, mathematically, this is the meaning. Suppose true is 1 and false is 0. Now you're working with binary number. That means only 0 and 1. In binary, there's no 2. The 2 is right as 1, 0. Okay, it's like decimal number 1, 2, 3, 4, 5, 6 up to 9. And then when you go to 10, you have one more digit and then go back to 0. So now in binary, we have 0 and 1. And that's it. And then what is not? Not is actually subtraction. And then what is ID? It's min. What is tautology? It's max. So basically, what the heck are these things? It's logic, right? Actually, it's mathematics with binary number. And we call this Boolean algebra. This is a guy, George Boole, he invented this many, many years ago. And this is exactly the mathematics inside a computer. Okay, this we'll talk about later. And then here's an example. B, the color of the door is black. So I have a B, I use B. What's not B? Not B means not black. You cannot say, oh, the door is white, the door is yellow. No, because not black can be yellow, can be blue, can be green, can be white, can be anything. And same thing. Let's say D means I support Donald Trump. What is not D? Not D just means I do not support Donald Trump. If you say that, no, that means I hate Donald Trump or I don't care, that's wrong. We are talking about logic. I just said I didn't support Donald Trump. It doesn't mean I hate him. And here's the funny thing. Isn't we have something called forced dichotomy or forced dilemma? The law of excluded middle is only on the true value of P. It says that the P can either be true or false. The content inside P, we don't care. So, for example, the color of the door is black. Then this is a statement, it's a proposition, it's either true or false, right? The content inside is, if I consider the negation, that means not black, the content inside can be yellow, can be blue, can be green, can be red. These have more than two choices, right? But this whole thing inside is still a proposition. This statement is either true or false, right? So this thing, this either true or false is exactly what excluded middle is about. It's not about what is happening inside the sentence. We don't care, okay? We talk about logic, okay? And here's another example. Suppose a set C is compact and convex. Okay, you don't know what the heck is going on. What the heck is compact? What the heck is compact? If you don't know, doesn't matter. What is not C? Not C is basically you just say a not, okay? The set C is not compact, not convex. This example basically means that if you give me some statement, I don't need to know what the heck is going on inside statement. I just add a not, then done. You don't need to know what the heck is going on inside. Same, this is called axiom of choice. This is a proposition. Not it. Then you just put a not. You don't need to know what the heck is going on inside. You don't need. Why? Because if every sentence we need to know what's inside before we do a not, then a lot of statement we cannot say not. Then there will be trouble. Okay? So these are the examples. So the basic unary operator is just not identity, tautological, contradiction. These three are boring. This one is the most interesting one.